Hey, welcome to The Explainer. We tend to think of AI and automation as, well, kind of like magic, right? Something that just happens in the cloud. But what if I told you that this whole revolution runs on a very real, very physical foundation? Today, we're going to get our hands dirty and dig into the real guts of the machine to see what actually makes it all work. So, what is the hidden link between these massive AI data centers, the electric car that might be in your garage, and the humanoid robots that are literally stepping out of science fiction and onto our factory floors? The answer is something surprisingly physical, and let me tell you, it's one of the most critical resources of the 21st century. All right, so let's start with the big picture here. Right now, there are three massive technological shifts all converging and honestly reshaping our world at an incredible pace. First up, AI is, well, it's breaking out of the digital realm. The tech giant NVIDIA actually has a name for this. They call it physical AI. And get this, they see it as a staggering $50 trillion industrial opportunity. We're not just talking about software anymore, folks. This is AI with hands, with wheels, and a real tangible presence in our world. Second, you've got the electric vehicle transition. It's happening way faster than a lot of people predicted. But this shift isn't just about swapping gasoline for batteries. It's fundamentally changing the material demands of the entire auto industry. And third, the moment we've all been waiting for, the arrival of humanoid robots. And listen, this isn't some far-off concept anymore. Tesla is already running pilot programs for its Optimus Gen 3. UBTech just signed a deal to put its Walker S robots in Airbus factories. They are officially on the job, right now. Which, of course, brings us to the crucial question. These incredible advancements aren't built from thin air, right? So, what are the actual raw materials? What are the physical building blocks that make this entire revolution even possible? Okay, let's dive into that, because the future isn't just being written in code, it's being forged from some very specific and, frankly, increasingly sought-after metals. Just to give you a sense of the scale of this change, think about this. A single electric vehicle can require up to 4 times the amount of copper as a traditional car with an internal combustion engine. 4 times. That's huge. And that's because copper is truly the metal of electrification. Those power-hungry AI data centers, they need tons of it. EV motors, charging networks, they all run on it. The renewable energy grids that power everything, yep, all dependent on copper. It's literally the circulatory system for this new physical digital economy. Now, the second key ingredient is a special class of magnets called permanent magnets. Now, these are mainly made from what we call rare earth elements like neodymium. What they do is create these incredibly powerful magnetic fields, which are absolutely essential for the compact, high-performance electric motors that power everything from your EV to the most advanced robots. So this slide right here is where it all really comes together. Just look at the pattern. AI data centers are just hungry for copper. EVs and renewables, they need both copper and those rare earth magnets. And advanced robotics, you guessed it, they use those same powerful magnets, plus other specialty metals like tungsten for strength. It's like a shared shopping list for the future. So how do these materials actually create better robots? Well, they're enabling a fundamental leap in the technology. They're helping us move beyond those clunky, caged-off robots of the past to something, well, something far more sophisticated. A huge part of this leap is happening deep inside the robots themselves. The entire industry is moving away from messy, high-maintenance hydraulic systems and shifting towards these highly efficient, oil-free electromechanical actuators. This allows for way more precision, lower maintenance, and much higher energy efficiency. It basically makes robots suitable for much more complex tasks. And this technological shift is exactly what's making the rapid rise of humanoids possible. Like we said, Tesla's Optimus is already in trials, UBTech's robots are heading to Airbus, and NVIDIA is even creating a foundational AI model. They call it GROOT, specifically to help other companies develop their own humanoids even faster. I mean, this is happening now. So naturally, this massive demand and this huge dependence on just a few key materials has kicked off a global scramble. The race is officially on to control the supply chain, from the mines where these metals are dug up, all the way to the factories that turn them into finished products. And this race has created some pretty significant geopolitical tension. For example, China, which pretty much dominates rare earth processing, has placed export restrictions on these crucial elements and the magnets made from them.
It's a clear demonstration of how access to these materials can be used as strategic leverage. And this quote right here shows you the real-world fallout. That's Vivek Vikram Singh, the CEO of Sona Comstar, a major Indian auto parts maker that supplies giants like Tesla. He's making it crystal clear. When the global supply chain gets squeezed, countries have no choice but to start building their own. And that is exactly what they're doing. India has launched this massive 73 billion rupee initiative to create a homegrown magnet ecosystem. It's a really comprehensive plan, designed to control the final, most crucial stages of production, from processing the raw oxide all the way to manufacturing the finished magnet. This chart shows you exactly why that investment is so critical. India's domestic demand for these permanent magnets is forecast to nearly double by 2030. Without a secure domestic supply, their entire high-tech manufacturing sector would be at serious risk. Okay, so with all this change happening, where are the opportunities? Let's take a look at how an investor might think about this massive physical transformation that's underpinning our digital world. So one way you can invest is through ETFs that are focused on automation. But here's the thing, they aren't all the same. For instance, you have an ETF like BOTS that puts a lot of its eggs in one basket, with a big chunk in a giant like NVIDIA. Then you have an ETF like Robo, which spreads the investment out over many different companies, big and small. It's a classic choice, right? Do you bet on the superstar, or do you bet on the entire team? Which leaves us with this final thought. We've established that the future of AI, of mobility, of automation, it's all being built with a very specific set of physical materials. So as the demand for these resources just explodes, the critical question becomes, who will ultimately control the building blocks of tomorrow's world?